Let's take a look at example 3 from week 11. In this example, we are now given some slightly more complicated quadratic factoring to do. Our previous algebraic example involved simple quadratic factoring. You should notice that the big difference here is that in our previous quadratic factoring, we didn't have these constant terms on the end. Our previous factoring problems have only involved there being an x term in every single term. This plus 6, this minus 24, that's really the thing that should be the red flag to you that says we need to actually perform quadratic factoring here instead of just our basic remove the common term factoring. As we've seen from the notes, what our intent here is to recognize that if we're going to get into factored form, then what we need to identify is what choice of numbers can I choose for my two constants in factored form so that these two numbers have a product of 6, the C term, and have a sum of 7, the B term. Over here, we'll do the same thing. We'll say, I need to choose two numbers that have a product of negative 24 and a sum of negative 2. If we can identify those two numbers, we'll be factored. What I generally do here, my little bit of side work that I'm going to show, is always going to start with my C term, in this case 6. And I'm going to make my product pair list for 6. What are all the ways that I can multiply two numbers to get 6? Well, I know that I can do 1 and 6. I know that I can do 2 and 3. And what's also true here is that there should be some negative pairs that go along with these. Negative 1 and negative 6, those two things multiply to 6. Negative 2 and negative 3, those two multiply to give us positive 6 right there as well. These seem to be all of the ways that I know that I can multiply two integers together and arrive at the product of 6. What we would like to do is choose from this list the pair that also adds to 7. What I can see here is that there's only one pair in my list that's going to add to 7. It's going to be the 1, 6 pair right there. Positive 1 and positive 6. I'm going to write a little bit more than I typically write in this case here to help kind of emphasize my thought process here. So my first thought in my process is, I know I'm going to factor into something of this form. Now I've identified that 1 and 6 are the numbers that I am thinking of here. Positive 1 and positive 6. We now are back in our zero product property scenario. Our zero product property, just like we saw in the last video, says if I ever multiply two numbers together and get 0, it must be the case that one of the numbers was 0. There's no other way to multiply and get 0 unless one of your multiplicands was 0, one of the terms in the multiplication, one of the factors. So I can go ahead and individually set x plus 1 equal to 0. I can also set x plus 6 equal to 0. I'm interested in knowing all the different ways that this equation could be true. One way it could be true is if this term is 0. A different way that this equation is true is if this term is 0. What value of x causes our first term to be 0? Well, not too terribly difficult here. It looks like negative 1 is our first answer. Same thing over here. Subtract 6 from both sides, and we're going to see that negative 6 is going to be our other answer here. So it looks like these are the two answers. These are both values of x that cause this original equation to be true, that this expression on the left is equal to 0. Slightly more exciting example over here. We want to do the same process. We're just going to see that we're going to get a few more choices out here. Before we do that, I'd like to back up to this product pair list that I made here. And let's tighten this up a bit, because what I'm not trying to do is do a bunch of work I don't need to do. When I look at each of the terms in this quadratic here, they are all positive, 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 positive. What that means to me is I know for sure that I'm going to be picking only positive terms for my breakdown here. There is really no way that these two are ever going to be the choice. These two terms are clearly going to add to be negative, and I'm not adding to be negative. I'm adding to be a positive 7. So I think it was kind of trivial for me to write those. That was really unnecessary. I could have just written those two and selected the 1, 6. Very similarly over here, I see that we are going to be multiplying two numbers to get negative 24. So what I know is that I have to have one positive number and one negative number. That's the only way you're going to get negatives out of multiplication, is if you have one positive and one negative. Further, I know that whenever I add this positive and negative number together, I know that I'm going to end up with a negative number. What that means to me is between the positive number and the negative number, the negative has to be the bigger of the two. Otherwise, we wouldn't have resulted in having a negative as a result of their addition. So I'm going to make this product pair list a little bit smarter. And that matters, because this was an easy product pair list. 24, it turns out, has a lot more choices out there. I don't want to write out all the ones that I know aren't part of my possible solution here. So when I make my product pair list for negative 24, the two pieces of information I'm going into this with are, I know that I'm looking for one positive number and one negative number. I know that I'm looking for the negative number to be the larger of the two numbers. So all the product pair items that I'm going to put over here are going to have one positive, one negative, and the larger of the two is going to be the negative. In this case, what I see here is 1 and 24, with the larger one being negative. 2 and 12, 3 and 8, 4 and 6. The next number I would check would be 5. But 5 times 5 isn't it. After that I would check 6, but we've already checked 6. It's associated with a 4 right here. So it looks to me like if I am hunting for my factored form, I need to choose which product pair is going to both have a product of negative 24 as well as have a sum of negative 2. In this case, all of these have a product of negative 24, but only one of them I can add together to arrive at negative 2 for my B term here. So I'm going to choose the pair 4, negative 6 for my factored form, plus 4, negative 6. And now we can immediately go to finding our solutions. Notice from this previous example here, I'm quite hopeful that you don't necessarily need to show this line of work right here, but in our later examples that get a little bit more complicated, we're really going to want to show this line of work to make sure that we don't make any small mistakes once things get tougher. So I wrote it here, but in general, in these simpler cases, I'm hopeful that you can just jump immediately to stating your solutions here. Negative 4 would join with positive 4 to make 0, and 0 times anything is 0. Similarly, a positive 6 here could join with a negative 6 to make 0, and 0 times anything is going to be 0. So it looks like in this case we can state our two solutions to this quadratic equation as negative 4 and 6 are the two values of x that make this equation true. One other thing we should do before we look at our third example here is we should verify. What's very, very, very common in this problem is for people to do a good job of recognizing that, for example, 6 and 4 are the numbers that are needed, but often I'll see a lot of people just get a sign wrong. Maybe make this negative and make this positive, or maybe make them both negative, something like that. You should remember that you can always check your answers very easily here. If I just FOIL out my factored form, I can verify that it's going to be the same as my original. F in FOIL stands for first. First times first is x squared. Outer two terms, x times negative 6 is negative 6x. I stands for inner. Inner two terms are 4 and x. And last two terms, 4 times negative 6 is negative 24. We just do a little bit of simplifying here. X squared, it looks like we got the desired term in the middle of negative 2x minus 24. So I feel pretty good that this was the correct factored form, and I feel very good that this factored form results in these two solutions right here. Let's go ahead now and take a look at the third example associated with example 3 in section 11 here. And this one just has one additional step that we need to watch out for here. In this final example, we have 3x squared plus 18x plus 27 equals 0. Immediately, the thing that should make you the most uncomfortable here is that 3. That 3 is going to cause some actual problems for us in our upcoming problems, but right now we can handle this a little bit more simply. Remember that your goal is just to factor in general. There's lots of different ways factoring happens. So when I think factoring, one of the things that I think is factoring like quadratic factoring, but we want to remember that we've got other formats of factoring as well, like saying questions such as, is there anything common to all the terms that I could factor out? If I ask that question over here, the answer is no. This term only has x's and no constants. This term has only constants and no x's. So there's nothing that's common to all three of them. On the other hand, in this example, this has a constant and an x, a constant, an x, and just constants. So it seems like all three terms do have constants. Is something common to all three? Well, it turns out 3 is divisible by 3, 18 is divisible by 3, and 27 is divisible by 3. So my first step here is going to be to do some simple factoring of factoring out the 3 from this entire expression here. Now, what I have remaining in here is a quadratic that I think that I do know how to factor. I can go ahead, before I go ahead and make my product pair list, I'm going to identify positive, positive, positive. If everything's positive in your standard form quadratic, everything's going to be positive in your factored form as well. If I'm going to make 9, my two choices are 1 and 9 and 3 and 3. I am looking to choose the pair that adds to 6, and so I'm going to choose 3 and 3. And so it looks to me like this quadratic should factor as once again, I can go ahead and use my zero product property here. I want to show a kind of ridiculous thing that I kind of typically do associated with this to help us remember the more general version of this. I don't want us to just think only in quadratic terms, because this applies to tons of other scenarios as well. In this case, it really looks to me like I have 3 numbers being multiplied and I'm getting 0 out. This says to me A times B times C equals 0. Therefore, either A is 0, B is 0, or C is 0. And we're going to see some slightly different outcomes here. So the first question that I might ask is there any scenario in which 3 is equal to 0? I'm going to set my first factor equal to 0 and say, okay, what solutions does this provide for me? Well, hopefully what you're aware of is that the number 3 is never the same thing as 0. So it turns out that while this is one of the factors in our zero product property scenario, it doesn't provide us any solutions here. There is no value of x that will turn the number 3 into the number 0. The number 3 and 0 are different. And our second one here, in B, in x plus 3, we ask ourselves the question, is there any value of x that makes x plus 3 0? And you should say, yes, there is one. Negative 3 works. I can just subtract that over to the other side over there. Finally, we notice this factor is the exact same. This should also be telling us that x plus 3 equal to 0 gives us the solution of x equals negative 3. So it is the case here that we did get the solution of negative 3 and another solution of negative 3. When you're in algebra class, it's going to be really important that you identify that that did occur 2 times. In this class right here, we're not going to look like kind of super technically at what the difference is between having a repeated root or repeated solution versus just having the solution occur one time. So in this setting right here, I'm not interested in what we would refer to as the multiplicity if we were in algebra class. Here this has multiplicity 2 because it occurred twice. I'm not worried about any of that. As long as you can tell me here that x equals negative 3 is the only solution to this quadratic right here, then you're going to be in good shape.